Okay, so today we will be learning about a new chapter in chemistry in CRT, which is the atoms and molecules. Now, in atoms and molecules, we have to discuss the law of chemical combination. So, what do you understand by the law of chemical combination? The law of chemical combination states has two laws, which is one is the law of conservation of mass, and another one is the law of constant proportion or definite proportion. So, first one is law of conservation of mass. It states that mass can neither be created nor be destroyed in a chemical reaction. That means the sum of the chemical of masses before the reaction is equal to the products. That means the reactants is equal to the number of products. The mass of the reactants is equal to the mass of the products. For example, they have taken an example of barium chloride plus sodium sulfate is going to give us barium sulfate plus sodium chloride. Okay, so here what does this mean? You can see that the number of barium sulfate in the solution and the mass of the sodium sulfate, the mass of barium chloride and sodium sulfate in the test tube was 300.23 grams. And when the reaction took place and after the reaction was complete, the mass still is the same. So this indicated that the mass still remained the same no matter whether the reaction took place or not. Now we have the law of constant proportions. Now the law of constant proportion states that in a chemical reaction, the compounds of an element is always present in definite proportion by mass. For example, if I take water, water is always in a fixed ratio of 8 is to 1. That means whenever two elements combine, they combine in a fixed ratio by mass. That means if I take water anywhere, water in pond, water in lakes, water in rivers, anywhere, water will always be in the combined ratio by mass, which is 8 is to 1. How do we know it is 8 is to 1? Hydrogen, what is the mass? It is 1 U, atomic mass, 1 U. Oxygen is 16, but hydrogen, there are two atoms, which is 2 U, and this is 16, which is one oxygen atom. So therefore, I'm going to take 2 plus 16, which is 18 grams of water will be always present in a molecule of water. That means a molecule of water can give 18 grams. That is what if I add up the atoms. So they will always combine in the ratio of 1 is to 8. How that is 1 is to 8? If I divide this by 2 by 16, as I told you, it will be 1 is to 8 by mass. So 9 grams of water, if it is decomposing, it will give us 1 gram of hydrogen and the remaining 8 grams of oxygen, that is 1 is to 8 only, right? That means in 9 grams, 1 gram of hydrogen is formed and 8 grams of oxygen is released. Okay, if I heat 1 gram like that. Now Dalton's atomic theory. Now, Dalton's atomic theory is very, very common, and its most famous theory is that the matter is made up of tiny particles, which is called as atoms. Atoms are indivisible and they cannot be created nor be destroyed in a chemical reaction, which was the law of conservation of mass. Yes, law of conservation. And this was the tiny particles known as atoms. Everyone knows this. And atoms of a given element are similar to mass and its properties. Atoms combine in small whole number ratios to form compounds. This is very important. Again, this is similar to the law of constant proportion or definite proportions, where atoms will combine in fixed ratio by mass. A given compound, the relative number of any kind of atoms is constant. Atoms of a given element is similar in mass and properties. That means the atom of, if I take atoms of similar element, will have same mass and same chemical properties. Atoms of different elements will have different mass and different chemical properties. That can be one of the rules which can be stated as atoms can combine to form compounds also. Now, an atom is the smallest particle, as everyone knows, and which may or may not be existing independently but remains in all of the chemical properties. Atoms are even smaller than anything which can be compared. Atom is having a radius of 10 raised to minus 9 meters, nanometers. 1 nanometer is 10 raised to minus 9 meters. The atomic radius of an atom of a hydrogen atom is almost equal to 10 raised to minus 10 meters, or what's 1 Armstrong units. This is also called as 1 Armstrong units. The radius of an atom molecule of water is 10 raised to minus 9 meters. Now going to the next one, which is the symbols of atomic elements. So we know that letters of elements can be represented in terms of symbols, and symbols of some elements can be represented by one or more symbols of elements. So some of the elements can be represented by two letters. Some of the symbols of elements can be represented in one letter. If a symbol has only one letter, then it should be written in a capital letter. If it has two letters, one will be capital, another one will be small. The preceding one will be of a small one. If you take aluminium, it's having A capital, one small, aluminium. Argon, AR. Barium, BA. Boron is B. We don't take BO because BO doesn't exist, but still. Bromine, Br. Ca. Calcium. Carbon is Ca, we cannot take, so we take only carbon. Chlorine, CH, we cannot take, so we take Cl, because CH is something else. Nitrogen symbol is N. Oxygen symbol is O. Potassium is something which is different. Potassium is K. Its symbol is K. Nitrogen symbol. And okay, that is on that side. Sorry. Okay, I didn't notice that. Copper is symbol Cu. Fluorine is fluorine. Gold is Au. Hydrogen is H. We know iodine is I, and iron is Fe. Lead is Pb, which is called as plumbum. And magnesium is Mg. Nitrogen is natrium. Sorry, yes, nitrogen is N. Oxygen is O. Potassium is K, which is potassium is different. P is phosphorus also sometimes. That is why we use K for potassium. Silicon is Si. Silver is Ag, which is agarium. No, but silver has another thing. Silver is there, and then we also have sodium. Sodium is natrium. Sorry, sodium is natrium. Nitrogen is N. Sodium is natrium. I'm really sorry that before one was nitrogen is N. The down one, that is sodium, is natrium. Sulfur is S. Uranium is U. Obviously, potassium is also there, which is K. We generally use K as for potassium. Now, atomic mass, which is very small in size and mass and very small in determining its mass, is very difficult because it's very small. So what do we do compared to other atoms? Of course, atoms can be considered standard form. So therefore, comparing the mass of each and every element we can use, because calculating the exact weight, predicting that is really difficult. So in that case, we will be using an atom which is used as a standard form. We'll be using that as a comparing other mass, because carbon is actually an element which is found in each and every part in the universe. Therefore, in the world, everywhere, something or the other is made up of carbon. So therefore, carbon is taken as a standard, especially carbon 12. So using this, we will be defining one atomic mass unit. So one atomic mass unit is always equal to 1/12 the mass of carbon 12 isotope. So the atomic mass of an element is defined as an average mass of an atom of an element compared to 1/12 the mass of carbon 12 isotope. Then atomic masses of some elements, you can see hydrogen, carbon, sodium, oxygen. This is one atomic mass unit which is equal to 1/12 the mass of carbon, which is 1/12 of 12th, which is how much? 12 only, right? I mean 1. Carbon is 12. So 12 of 1/12 is, I mean, 12 of 1/12 will be 1, but of course here if you see 1 of 1/12 mass of carbon atom, that is 12 atoms of hydrogen, so it is 1 atomic mass unit. Like that it is calculated, but usually we don't calculate that. So atomic mass of one element is 1 hydrogen, and carbon, nitrogen, oxygen, sodium, we have the respective atomic mass numbers. So if you talk about the molecules, if we talk about the molecules, we will be discussing about it here in the. So a molecule is the smallest number of particles of an element or a compound which exists independently and shows all the properties of that substance. So an example of a molecule is carbon dioxide. So we can have, it is the smallest part of an element. A molecule is the smallest part of an element. So these are two elements. It can be an element or a compound which is independently existing also, but it also shows, it independently expresses the substances. For example, carbon properties can also be exhibited in carbon dioxide. Oxygen properties can also be exhibited in so it's like a combination. So molecules, as I told you, it is the smallest particle of an element or a compound which exists independently, and it shows all the properties of that particular element. So molecule can be also having two or more elements that can be held together by attractive forces. So the forces can be ionic or covalent. So these will be discussed later. But if you see the atoms of same elements or different elements, they can together form molecules. Okay, so atoms of same element, that is oxygen, because O plus O, O2, or sodium, N plus O2, which is NO2. So basically atoms of similar elements can form molecules, or atoms of different elements can also form molecules. So it can in any way it can be forming molecules. So molecule is the smallest particle of an element which can exist independently and shows the properties of that substance. Okay. Now, if you discuss the molecules of an element, we have something which is called as the atomicity of an element. Atomicity is actually representing the number of atoms which can be present in one molecule of an element. So that means an argon, if you take argon, argon is uniatomic molecule or monoatomic molecule. So that is one atom. Similarly, oxygen is what? It is a diatomic because it has two atoms of oxygen. Similarly, nitrogen is N3, which is triatomic because it has three nitrogen molecules. Like that, hydrogen is diatomic. Nitrogen is diatomic in this case. Nitrogen is diatomic. Nitrogen is diatomic, but we also have N3 as well now. Yes, we have also N3, but O3 is also there. O3 is triatomic, right? So if they ask about polyatomic, polyatomic is S8, is a polyatomic, like more than 3 is polyatomic. P4 can be tetraatomic, but still we call it as polyatomic only. But we have tetraatomic also. Tetraatomic means which has 3. For example, ozone. O3 is ozone. So non-metals, these are non-metals. Non-metals will be having monatomic structure or diatomic structure. Metals will be also most probably monoatomic also as well. Now, if you talk about the molecules of a compound, so molecules of a compound means it contains atoms of two or more different elements. For example, water, carbon dioxide, nitrogen dioxide, ammonia, so etc. are these elements. So molecules of compound means compounds in which one or more molecules will combine to form a compound. So atoms of a molecule will combine to form a compound. For example, water is a compound where the combining elements are hydrogen and oxygen are individual elements. So these two individual elements of a compound of a molecule will form a compound. So ammonia is an example, nitrogen and hydrogen. So one nitrogen and three hydrogen molecules will form an ammonia. Carbon dioxide, one carbon and two oxygen will form carbon dioxide. Hydrochloric acid is hydrogen and chlorine. Nitric acid is HNO3. Similarly, sulfuric acid H2SO4. As you can see, like this, we can have different elements which can be formed. Now, coming to the ions. What are ions? Ions are charged particles. Charged particles. Ions can be categorized into two parts, cations and anions. Okay, so cations are something which is positively charged and ions are negatively charged particles. Okay, so that is something very important. So compounds, they lose electrons, or if they gain electrons, when they lose, they become positively charged element, which is known as cation. And when they gain electrons, they become negative, and therefore they got known as anions. So anions and cations will have fully filled electrons in their valency. So valency means what? Combining capacity of an element. Sodium is Na plus, potassium is K plus. I told you. What is K actually? Why potassium has K? Everyone knows why potassium has K. Potassium has is known as kalium. Yes, so potassium is known as kalium, and therefore we took K over there. Silver is Ag, argentum, then copper is cuprum, magnesium is copper, calcium, zinc, iron is ferrum, copper is again cuprum, we say. Copper one. So copper has three valencies, it's tetravalent. Again, based on the valency, we can say monovalent, divalent, trivalent. Yes, like that. So basically, copper has copper 1, Cu plus, Cu2 plus, and again Cu3 plus is also possible, but in very rare cases. Mostly we have Cu plus, and Cu2 plus. Cu3 plus is not there actually. Cu3 plus is not there. No, it's also known as copper 1. Okay, this is known as copper 1. And this is known as copper 2 with the Roman numeral. So this is aluminium. This is nitride N3. Oxide is O2 minus. Iodide is I minus. Bromide is Br minus. Cl minus. Chlorine hydride is H minus. Hydrogen is again H plus. So we have different types of like this. Ammonium, these are polyatomic ions. NH4 is a polyatomic ion. Hydroxide is OH minus. Nitrate is NO3 minus. Hydrogen carbonate is HCO3 minus. Carbonate is again CO3 2 minus. Sulfite is SO3. Sulfite and sulfate, students get confused. SO3 minus, SO3 2 minus is sulfite. SO4 2 minus is sulfate. And phosphate is PO4, PO4 3 minus. Okay. Yes, and then we are coming to the next part, which is the writing of chemical equations. So first, what you need to do is that after you have learned the formula, after you have learned the names, how to represent the symbol, and once you have learned all of that, you have to know how to form the chemical formula. Chemical formula is very important. You have to know how to write the symbols and formula of elements of ions. How to do that, basically you must know. So if you have, for example, sodium and sulfate, So sodium, if I talk about that, it is sodium. So if I talk about sodium, sodium is, what is the valency? +2. SO4 is -2. Yes. But yes, and any sodium is not +2. In this case, it will be +1. Sodium is never +2, +1. Sodium is +1, and SO4 is -2. So just cross that, and if you cross that, you will get Na2SO4. So this is what a compound is formed. So when a compound is formed, basically, if you have to write the corresponding valency, and you have to cross it. Once you cross it, you will be getting the corresponding element. For example, sulfur and this one. If you take Al is +3 and the sulfur is SO4 is -2, right? Cross this and this, you will be getting AlSO4 thrice. This is the formula. This is aluminium sulfate. Similarly, if you take aluminium and chlorine, chlorine is -1 in charge, +3 in charge, just cross this, and if you write AlCl3. So like that, you have to cross the valency to that respective element to calculate and find out the polyatomic ions. You need to write the bracket like this. You need to write formula, and you need to write the valency formula and crisscross it to find out the valency of that element. Now the next one, calcium oxide. You can see calcium oxide, calcium is Ca2 plus, oxygen is O2 minus. So again cross, but calcium, it will be calcium oxide O2. So this will cancel and becomes calcium oxide. Sodium nitrate NO2, NO3 -1. This is +1. So it is NaNO3. And sodium carbonate Na, carbonate is CO3 minus. So this is +1. So cross this, so it becomes Na2CO3. Similarly, if you take Al2O3, similarly aluminium is +3, oxygen is -2, cross this, we'll get Al2O3. Similarly, calcium hydroxide, CaOH, calcium is +2, oxygen is OH -1. If you cross that, you'll get calcium OH twice, right? Like that formula of ammonium sulfate. Ammonium sulfate is NH4 is -1. SO4 is 2 minus. So if you cross that, what you're getting? NH4 twice SO4, right? This is the formula. Like this, you need to learn how to do the formula. Similarly, if you know how to calculate the molecular mass of an element, the sum of all the atoms in a particular element of a substance is what is known as formula mass or molecular mass. If you take water, water is hydrogen is 2 into 1, which is 2 U, and 1 is 1 oxygen, so 1 into 16, which is 16 U. So if I add these two, you will be getting 32, 18 U. This is the formula mass of water. Similarly, if you take HNO3, hydrogen is 1 into 1, which is 1 U. Nitrogen is how much? 1 into nitrogen, how much is there actually? It is 14, which is 14 U. O3 is oxygen, oxygen is 16, 16 into 3, which is again how much? 48 U, which is almost totally 63 atomic unit. Now, mole concept. This is a very important one. This is a very important concept which we need to discuss. So 1 mole of a substance we need to understand. 1 mole is actually defined as the number of atoms, number of molecules, or number of particles which is present in 12 grams of a carbon atom. So basically the number of atoms or molecules or ions which is present in 12 grams of a carbon isotope. This is what is known as 1 mole of a substance, and 1 mole is represented in terms of Avogadro number. Like how we have 1 dozen represents 12 bananas, or 1 dozen represent 12. Like that, 1 mole of any substance is represented as Na, or Avogadro number of molecules is 6.022 to 10 raised to 23 atoms, molecules, or particles, and this is known as Avogadro's constant. Yes, and therefore it is representing as a definite mass of a substance equal to the gram atomic mass of an element, or gram molecular mass of a compound. Gram atomic mass of an element means, if I take O2, means it is 16 into 2, just 32 grams of an element. If I take a gram molecular mass, this is the gram molecular mass because this is a molecule. So hydrogen is 2 into 1, which is 2U, and again oxygen is 1 into 16, which is 16, which is 18U, which is a molecular mass. The relationship between the number of moles and the mass and the molar mass is all represented in terms of this formula, and the formulas which I'm going which will be written as follows. So the formulas are, for example, the formulas are, I will be writing it here, 1 mole. So if I need to calculate the number of moles, actually the formula is confusing here. So if you write given mass by molar mass of a substance, this is equal to 1 mole of a compound. 1 mole of a substance is equal to given mass by molar mass. Similarly, if we can also write it as 1 mole of a substance is also equal to number of particles by Avogadro number. Na is also known as Avogadro number, or Avogadro's constant, which is 6.022 into 10 raised to 23. So if I combine these two, what I'm going to get? The formula will become, another formula is number of moles. These two sides are equal now. These two sides are equal. So therefore, I can say number of particles by Avogadro number is equal to this, given mass by molar mass. This is explained here as follows. So this is the end of the chapter. The chapter is completed. The theory session is completed. The problems will be shortly discussed after once the theory session is done. Thank you once again for listening to my video. Hope to meet you in the next class. Thank you.